This conference will now be recorded.
Good morning, students. In today's class, we are going to start that fourth unit, that is single phase transformer. Already, you guys are know about what is the purpose of transformer we are using in electrical system. So we have number of electrical components we are using in daily life, right? Like motor, generator, but the transformer having that importance role in the electrical system. So what is the importance means? So it's we can easily so you can compare that transformer like a human body. So how it means for human body, what is the importance of heart? So that much of importance have by that transformer in electrical system. Generally, what is the heart will do in a human body? It is circulating the blood in a purified manner. The same thing, transformer also having the same role in the electrical system. That's why when compared to the motor and generator, it has the more importance. And one more advantage having that the transformer is losses. So when compared to motor and generator, the transformer having the less losses. So why? Because do you know that? Why transformer having the low losses when compared to motor generator? Why transformer having the less losses when compared to motor generator?
సార్ ఇన్పుట్ ఎలక్ట్రికల్ ఎనర్జీ ఇస్తాం, అవుట్పుట్ కూడా ఎలక్ట్రికల్ ఎనర్జీనే ఉంటుంది సార్.
Yes, and one more thing, there is no mechanical losses. That is the reason we are getting that less amount of losses in the transformer. So that's why in the efficiency point of view, how we can represent that these three devices, that is motor and generator. So motor, the first thing is motor, generator and transformer. So already we obtained that efficiency of motor and generator by using the Siemens test. We are getting that low amount of efficiency for motor, and for generator we are getting that medium, and for transformer we are getting that high efficiency. So this is the three devices can be differ by using the level of efficiency. Generally, the motor is always having that efficiency is less than 50%. This is the motor efficiency, and generator efficiency is always lies in between 50 to 70. And the transformer is having that efficiency is 90 to 95%. So why this much of efficiency is differ among these three devices means, if you take the motor here, for motor we are giving the electrical energy as input and getting the mechanical output. But here the mechanical load is connected through the shaft. So this is the load, and through the shaft we are connecting the motor. And in this shaft there are losses happening in the terms of loss term. That's why the motor efficiency is always low when compared to the generator and transformer. But in the case of generator, we are getting less amount of torque losses. That's why the efficiency is lies between 50 to 70%. Now, if it, in the case of transformer, here there is no mechanical losses. That's why we are getting the 90 to 5%. Now, by seeing this efficiency levels, we can easily say that the transformer is the most important device we are using in the electrical system, and we need to be protect more than these two devices. So we have to give that much of importance on the transformer because of this reason. Now we will see this, what is the transformer, what is the purpose, and where we are using. So first of all, before going to the subject, you have to know that what is the purpose of transformer and where we are using the transformer. So generally, you guys all know that the transformer is used to step up or step down the voltage. Okay. Now, if the transformer is having the step up, then we can call as step up transformer. If the having that step up, step down voltage, then we call it as step down transformer. Right now, our intention to know that where we can use step up transformer and where we can use step down transformer. అంటే step up transformer అనేది ఎక్కడ యూజ్ చేస్తారు, step down transformer అనేది ఎక్కడ యూజ్ చేస్తారు. So that is the thing you need to know that. So I will tell you that. So in electrical system is categorized into three categories. One is generation, second one is transmission, and third one is distribution. Now the power generated by the generating station, it should be delivered to the load through the transmission lines. Now if you observe this generating station and load, it is a huge amount of distance between these two parameters. Now we need to transfer this power from generating station to load, that is distribution system, through the transmission lines. Now in between these two we are using one transformer here, and here also we are using one transformer, but we have to know that what type of transformer we are using here, that is step up or step down. The same thing here also. Now generally in India, entire India, every power plant can be generate the power in terms of 6.6 kV, 11 kV or 33 kV. These are the three ratings of power, that is voltage generated by the generating stations in entire India. మన ఇండియాలో ఉండే ప్రతి ఒక్క పవర్ ప్లాంట్ అనేది ఈ లెవెల్ వోల్టేజ్ ని జనరేట్ చేస్తుంది. ఈ లెవెల్ వోల్టేజ్ అంటే దాని బేస్డ్ ఆన్ కెపాసిటీ. కొంచెం స్మాల్ ఇండస్ట్రీ, స్మాల్ జనరేటింగ్ ప్లాంట్ అయితే 6.6, medium 11 kV and maximum 33 kV. So these are the three ratings of voltage levels generated by the generating stations. We have number of generating stations like thermal power plant, hydro power plant, nuclear power plant, diesel, solar, wind. So by using this type of power plants, we can generate the voltage levels 6.6, 11 kV and 33 kV. Now so we can't able to transfer this voltage because from generation station నుంచి distribution కి ఎక్కువ distance ఉంది. మనం ఇదే వోల్టేజ్ లెవెల్ కనుక ట్రాన్స్ఫర్ చేస్తే ఏమవుతుంటే ఫైనల్ గా మనకు లో అమౌంట్ ఆఫ్ వోల్టేజ్ అనేది వస్తుంది అన్నమాట. నౌ వీ హ్యావ్ టు బి ఇంక్రీజ్ దిస్ వోల్టేజ్ లెవెల్స్ టు దట్ ట్రాన్స్మిషన్ లైన్. సో అది ఎలా యూజ్ అంటే, సో ఫ్రమ్ ద ట్రాన్స్మిషన్ లైన్ వీ కెన్ గెట్ 132 kV, 200 kV, 400 kV. This is the voltage levels having in the transmission system. ఇప్పుడు చూడండి, so here 6.6 kV that is generated by the generating station and this value becomes 132. Here increase or decreased? Voltage level ఎలా ఉంది? Increase and decrease అయిందా?
Increase అయింది sir.
Increase అయింది. Now let me tell you that what type of transformer we are using here. Step up or step down?
Step up transformer sir.
So the step up transformer we use in between the generating station and the transmission lines. So ఈ రెండింటి మధ్యలో యూజ్ చేసే ట్రాన్స్ఫార్మర్స్ అన్ని మనం స్టెప్ అప్ ట్రాన్స్ఫార్మర్స్ అంటాం because it is step up in the voltage. Now if you observe this, the transformer is located between the transmission system and distribution system. We can call it as a step down transformer. Why? Because this amount of voltage should be stepped down to the 230 volts and 400 volts. So ఇక్కడ మీరు చూస్తే ఇవన్నీ kV లో ఉన్నాయి, కిలో వోల్ట్స్. ఓకే, సో ఫ్రమ్ హియర్ you are getting finally you are getting the 230 volts and 400 volts. So 230 volts is single phase supply, 400 volts for three phase supply. Okay, so this is our finally we are getting the voltage. So if you observe these two voltage levels, so here the generating station generates 6.6 thousand volts, but finally we are getting that 230 volts and 400 volts. If you are not using the step up transformer, you will finally get 100 volts like that. So that's why we are stepping the voltage and transmitting the more distance. So we already transmission line వచ్చింటది ఈ PSL పవర్ సిస్టమ్ ఆర్కిటెక్చర్ లో లాంగ్ ట్రాన్స్మిషన్ లైన్, మీడియం ట్రాన్స్మిషన్ లైన్, షార్ట్ ట్రాన్స్మిషన్ లైన్ అంటే. ఓకేనా, సో ఈ త్రీ ట్రాన్స్మిషన్ లైన్స్ ని ఎలా కేటగిరైజ్ చేస్తారంటే బేస్డ్ ఆన్ ద డిస్టెన్స్, అంటే అవి ఎన్ని కిలోమీటర్ల వరకు ఉన్నాయి అండ్ బేస్డ్ ఆన్ ద వోల్టేజ్ లెవెల్స్. ఈ రెండు పారామీటర్స్ బేస్ చేసుకొని మన ట్రాన్స్మిషన్ లైన్స్ ని త్రీ కేటగిరీస్ గా పిలుస్తాం. వన్ ఈస్ షార్ట్ ట్రాన్స్మిషన్ లైన్, మీడియం అండ్ లాంగ్. ఓకేనా. సో దీన్ని బేస్ చేసుకొని మనం వోల్టేజ్ ని స్టెప్ అప్ చేసుకోవాలి. సో నౌ ఐ విల్ షో యూ వన్ వీడియో అండ్ యూ కెన్ గెట్ క్లారిటీ హౌ ద వై వి నీడ్ ద ట్రాన్స్ఫార్మర్ ఇన్ ద పవర్ సిస్టమ్. So while seeing this video, you can get clarity the importance of transformer in electrical power system.
The electricity generated in a power plant needs to be transported to the cities and distributed to all the electrical loads. To reduce power losses, we use high voltage transmission lines with voltage level of hundreds of kV, which are connected to our transformer. Inside the transformer, the current goes from a coil to the other by means of a mutual coupling between electrical circuits to obtain a lower voltage level, usually 11, 20, or 36 kV. From the power transformer, the electricity runs through the distribution network to reach small substations, where the voltage level is further reduced to low voltage to directly supply lights and motors. As the load increases, the power losses on the line are also increasing. Therefore, we need to adjust continuously the voltage level by changing the number of turns on the winding. The tape changer maintains a stable voltage level as the load changes during the day. To have a closer look at the transformer, we start by removing the external accessories and bushings to get access to the active part inside. We then remove the tap changer and the upper tube to get access to the windings. The coils are mutually coupled by the magnetic circuit connected to the tap changer and then placed into the oil tank that will be then filled with oil. On the tank cover, we place the bushings, the expansion vessel, the radiators, and the cooling fans.
So this is the importance of transformer, that is the delivering the power from generating station to distribution. We need in between these transformers. So well, I will show you that what are the voltage levels having in the electrical system, and this is the most important general topics. So this is the voltage levels. We are having that in three categories, three sectors. One is generation, transmission, and distribution. In generation, we are getting the voltage 6.6 kV, 11 kV, and 33 kV. After this generating stations, by using the step-up transformer, we are increasing the load to 132 kV, 220 kV, and 400 kV. Now after that, after transmission line, we have two substations. One is primary substation and secondary substation. So in primary substation, what you will get means this all levels of voltage reduces to 66 kV, and this 66 kV will be reduced to 11 kV, so 33 kV. In secondary distribution, what we are getting 33 by 11 kV. So we are seeing the substations in our local areas, right? That is 33 by 11 kV. It means that the primary voltage is 33, and secondary voltage is 11. After this voltage, this 11 kV will be transmitted to the distribution transformers. What we are using in our streets, that is called as distribution transformer, and that transformer will be reduced this 11 kV to 230 volts or 400 volts based on our voltage level, supply voltage. If it is single phase, this 11 kV will be reduced to 230. If it is three phase, this 11 kV will be reduced to 11 volts. Sorry, 400 volts. This is the voltage levels having in the power system. Now, according to the necessity of voltage, that is how much of voltage you need to be required, based on that we have to be increase or decrease by using the step up and step down the transformer. The only effective device is required for this purpose is transformer. So this is the definition of transformer. So what you can do is, for according to that necessity of voltage levels, we need to be increase or decrease the voltage. Now for this purpose, the only device it is capable to increase or decrease device, that device is called as transformer. Now we'll see that what are the parameters are including in the transformers. If you see and if you seen in the generator motor, we discussed different parameters like armature, commutator, brushes, field winding, pole shoe, yoke. So these all parameters which is belongs to that transformer, that is motor and generator. Now in the case of transformer, that completely dealing with these parameters, that is voltage, current, frequency, phase, waveform, harmonics, power factor, active power. So we can call it as a real power and reactive power, apparent power. These are the parameters and components deals with to explain about transformer. So voltage, that is we are giving the input voltage, and when we apply the voltage here, the current will be flowing the circuit. And frequency, for AC supply, we have the frequency is 50 hertz. For AC supply, the frequency value is 50 hertz. For what about DC supply? What is the frequency of DC supply? Zero. There is no variation happening in the DC supply. So I will tell you how it will be. If you consider that AC, that is sinusoidal parameter, it may be voltage, current, or power. If you observe this parameter, if you observe the graph, the parameter is going to be changed based on the time period. So here it is 0, here it is maximum, and it is 0. Again it comes to the negative. So it means that this parameter is keep on going to with respect to the time. So already you know that the relation between the time and frequency. What is the relation? Directly or inversely proportional? What is the relation between time and frequency?
T equal to 1 by f, sir.
Right. The time period is inversely proportional to the frequency. Now, where the parameter is keep on going to be changed with respect to time, that having the frequency is 50 hertz. In entire India, the AC supply having the 50 hertz frequency. Now, let me see the phase angle. So, phase angle in the sense, we having that two parameters, right? Voltage and current. Now, our condition, our intention is how the voltage and current should be. Suppose if you consider this graph like this, it is current and it is voltage, and the angle between this voltage and current we can call as phase angle. So that is represented by the phase. And waveform is, it is sinusoidal. If you want to draw the cosine, that is cosinusoidal, it should be like this. Okay, sinusoidal ఎప్పుడు 0 నుంచి స్టార్ట్ అవుతుంది, cosine form ఎప్పుడు maximum నుంచి స్టార్ట్ అవుతుంది. అది పాజిటివ్ అయితే పాజిటివ్ నుంచి, నెగటివ్ అయితే నెగటివ్ నుంచి. ఓకేనా. నెక్స్ట్ వన్ ఇస్ హార్మోనిక్స్. ఇన్ ట్రాన్స్ఫార్మర్ ద మేజర్ ప్రాబ్లం సిచ్యువేటెడ్ బై ద హార్మోనిక్స్. హార్మోనిక్స్ అనేవి చాలా డిస్టర్బెన్సెస్ అనేవి క్రియేట్ చేస్తారు ఈ ట్రాన్స్ఫార్మర్. అండ్ I want to tell you that how we can determine the harmonics. అనే హార్మోనిక్స్ ని ఎలా ఐడెంటిఫై చేస్తారు, ఓకేనా. సో హార్మోనిక్స్ ఐడెంటిఫై చేయడానికి మనకి సపరేట్ గా ఏ డివైస్ లేదు, లైక్ అమ్మీటర్, వోల్ట్ మీటర్ లాగా. సో హార్మోనిక్స్ ని ఎలా డిసైడ్ చేస్తా చెప్తాను. సపోజ్ యువర్ వేవ్ ఫార్మ్ ఈస్ లైక్ దిస్. దిస్ ఇస్ ద ఇన్పుట్ వోల్టేజ్. ఓకేనా. యు ఆర్ అప్లైయింగ్ ద ఇన్పుట్ వోల్టేజ్ and its waveform is like this. Now you are getting the voltage waveform, that is output voltage, it should be like this. See, if you observe these two waveforms, what you can observe, this is the input waveform, it is output waveform. What you observe from these two graphs? ఏమైనా డిస్టర్బెన్స్ ఉందా? అంటే డిస్టర్బెన్స్ అంటే వేరియేషన్.
In second wave, some fluctuations are there.
That fluctuations is made by that harmonics. Harmonics ఉండడం వల్ల ఆ ఫ్లక్చువేషన్స్ అనేవి క్రియేట్ అవుతాయి. ఓకేనా? సో ఇక్కడ మనకు హార్మోనిక్స్ అనేవి డిఫరెంట్ ఫార్మ్స్ లో చేస్తారు. ఈవెన్ హార్మోనిక్స్, ఆడ్ హార్మోనిక్స్ అని. ఈ హార్మోనిక్స్ వల్ల ఏమవుతుందంటే మనం పవర్ క్వాలిటీ అనేది తగ్గుతుంది. when the harmonics are present, the quality of power will be reduced. That's why we are using the filters to reduce the harmonics. So filters ante capacitors anamata. Capacitors use cheskoni, then we can reduce that amount of harmonics. When the harmonics are reduced, we can get that quality of power. ఓకేనా? మనకు అప్పుడప్పుడు పవర్ వీక్ గా ఉంటుంది. సో వీక్ గా ఉండే రీజన్ ఏంటంటే బికాస్ ఆఫ్ హార్మోనిక్స్. హార్మోనిక్స్ అనేది ప్రెజెంట్ అవ్వడం వల్ల ఏమవుతుంటే వీఆర్ నాట్ గెటింగ్ దట్ క్వాలిటీ ఆఫ్ పవర్. If you are not getting the quality of power, then your devices using in a home, it is not working sufficiently. That's why our intention, we need to reduce the harmonics by using the filters in the form of capacitor. Next, power factor. So already I told you that what is the importance of power factor in the electrical point of view. So the power factor gives that how much of power which will consume by the device. So we have the three types of power factors. One is unity power factor, lagging power factor, and leading power factor. So when you will get this type of power factor means when your load is resistive load. So load అంటే మనం ఎప్పుడైతే మనం ఒక రెసిస్టివ్ లోడ్ అనేది ఇప్పుడు మనం డివైసెస్ యూజ్ చేస్తాం, టీవీ కానీ, మిక్సీ, ఫ్యాన్, రిఫ్రిజిరేటర్, దిస్ ఆల్ డివైసెస్ బిలాంగ్ టు ద లాగింగ్ పవర్ ఫ్యాక్టర్. దీన్ని ఇండక్టివ్ లోడ్స్ అంటారు. ఓకేనా? When you are using the resistive load, then you will get that unity power factor. So ఎప్పుడైతే మీరు రెసిస్టివ్ లోడ్ కనుక యూజ్ చేస్తారో then it having that unity power factor, then it requires that less consumption of power. Now when you are using the inductive loads in the sense what we are using now in our homes like TV, refrigerator, mixie, washing machine, this all under device belongs to that inductive loads, and these loads having the lagging power factor. Lagging power factor in the sense this device's power factor is always less than 1. It may be 0.2, 0.4, 0.6, 0.8. These levels of power factor are mentioned in star, 3 star, 2 star, 4 star, like that. And when the power factor is more than 1, we can call it as a leading power factor. The loads having lead power factor is capacitive load. So the capacitive load having that leading power factor. That is about power factor. Next one is active power. So we can call it as active power like a real power. So real power in the sense the power which is generated by the generating station, we can call it as a real power. Okay, so generating station నుంచి generate చేసిన పవర్ ని మనం రియల్ పవర్ అంటాం. And the power which is transmitted through the transmission line, we can call it as a reactive power. Okay, why reactive power is forming means because we already transmission line parameters గురించి చదివారు. Transmission line parameters ఏమేమి వస్తాయి? What are the transmission line parameters?
H parameters, ABCD parameters.
Transmission parameters అంటే like resistance, inductance and reactance. ఓకేనా? R, L, రెసిస్టెన్స్, ఇండక్టెన్స్ అండ్ ఇంపిడెన్స్ Z. ఓకేనా? మీరు ఆల్రెడీ ZEQ, LEQ కనుక్కుంటాడు, ఇండక్టెన్స్, ఇంపిడెన్స్. ఓకేనా? through between the conductors. Now if you observe the transmission line, it is the combination of resistance and reactance, that is inductance. That's why it is the combination of resistance and reactance. That's why the power transmitted to the transmission line we can call it as reactive power, and the combination of both real power and reactive power we can call it as an apparent power. These are the parameters and these are the components we can talk about in the performance of a transformer. Now we'll see that what type of transformer we have based on the different scenario. And before that, we will see that how the energy will be converting from one form to another form in which way. Generally, the energy should be converting in three modes. What are the three modes means? The first mode is conductively, second mode is mechanically, third one is inductively. Conduction, mechanically, and inductively. These are the three modes the energy will be converting. So in these three modes, the energy converting from one form to another form, or else same form to same form. Okay, now let me see that the first one is conductively. In this case, what is happening means when we are applying the voltage like 100 volts, right? When you are applying the voltage across the conductor, this is the conductor here, and you are getting the same amount of voltage as output. That is called as conductively. అంటే మనం ఎంతైతే ఇన్పుట్ ఇస్తామో సేమ్ అమౌంట్ ఆఫ్ ఇన్పుట్ అవుట్పుట్ కనుక తెచ్చుకుంటే దాన్ని ఆ ట్రాన్స్ఫర్ ఆఫ్ ఎనర్జీని కండక్టివ్లీ అంటాం. See here, just see this sentence. To transfer electrical energy in the same form. Same form means if it is electrical energy, you are getting the same input and same output. An ideal conductor transfers electrical energy without changing its characteristics. Characteristics in the sense, if you are applying that 100 volts, the same voltage levels you are getting here. And when the energy is in the electrical form, its voltage cannot be increased. So it should not increase. So what amount of voltage you are giving the input, the same level of voltage you are getting the output. It never be increased, never be decreased. This type of energy conversion we can call as a conductively energy conversion. Now we will see that next mode, right? Mechanical. So what are the devices which is belong to this second category? మనకి ఏ డివైస్ అనేవి మెకానికల్ ఫామ్ కలిగి ఉంటది? What are the devices we have that mechanical energy? So we have the three main devices, right? Motor and generator, transformer. Out of three, which device is having that mechanical energy? It may be input or output.
Motor and generator, sir.
Right. Motor and generator are having that mechanical. So if you consider that motor, we are applying the electrical energy and getting the mechanical energy. So here the energy should be converting from one form to another form. So here we are representing the power in terms of watts, that is electrical power. But in the form of mechanical power, we can represent that in the terms of torque, speed, like that. So this type of energy mode should be converted in terms of mechanically form. Next, third one is inductively. Inductively means that when the voltage levels, so ఇప్పుడు మన ఇన్పుట్ వోల్టేజ్ ఎంత ఇస్తామో దానికి అది కాకుండా it may be increase or decrease. So when the voltage levels should be vary with respect to the different parameters, in that case we can say that inductively conversion. So that's why I already told that every electrical machine should be working on that Faraday's law of electromagnetic induction. So Faraday's law of electromagnetic induction means the value of voltage should be depends on that how many number of conductors we are using in that device. Suppose if you take the generator, right? We are applying the mechanical energy as input and getting the electrical energy as output. And this electrical energy should be depends on that number of armature conductors and the speed. Okay, now if the number of armature conductors increases, voltage also increase. If the speed is increases, voltage also increase. So based on the parameter, అంటే ఇండక్టివ్ అంటే మనం ఇచ్చే ఇన్పుట్ అనేది సేమ్ కాకుండా ఇంక్రీజ్ కానీ డిక్రీజ్ కానీ చేస్తే దాన్ని కన్వర్షన్ ని మనం ఇండక్టివ్ కన్వర్షన్ అంటారు. Now we can say that simply the transformer is working of Faraday's law of electromagnetic mutual induction. So why this term is added here means in the transformer the primary is providing here and secondary is providing here. Now we are applying the voltage V1 in this primary circuit and getting the secondary voltage V2 on secondary circuit. Now when the voltage is applied to the any circuit, there is a allowing of current I through the circuit. Now when the current flow through the winding, the flux will be generated. That same flux will be flows to the secondary circuit, that is V2. Okay, now when the flux is connected to the V2, the same current will be flow, that is I2 and V2. So it means that the generating of voltage and current should be depends on that only flux. It is acting mutually with respect to the primary and secondary. That's why this transformer is a device, it will be working electromagnetic mutual induction. And here we can write E is equal to N into d pi by dt. From this you can easily reference that the amount of voltage is depends on the number of turns. If the number of turns is increases, the voltage level also increases. If the number of turns decreases, voltage level also decreases. So this type of energy conversion we can call it as a inductive link. So these are the three modes of energy conversion happening in the electrical device. Now we'll see that classification of transformers based on the different parameters. The first one is number of phases. So classification is one of the most important question from the fourth theory. Okay. So the transformer is classified based on the different parameters. In that, the first parameter is based on the phases. So we have the three types of transformers based on the phases. One is single phase transformer, three phase, and Scott connection. Out of three, we are using two transformers in real-time applications. That is in our real-time applications where we are using that home appliances, industries like that. And Scott connected transformer is only permitted to that laboratories. Why? Because this type of transformer we are not able to use in the real-time applications. Now, when compared to the single phase and three phase, this is having that different characteristics. So what is the characteristic means? Suppose if we take the single phase transformer here, and this diagram represents the single phase. You are giving that, you are providing the primary as a single phase represented by prime phase and neutral. And same thing you are getting here also, phase and neutral. So this is a single phase transformer. If you take that three phase transformer, you are having that three phase R, Y, B, and the same level of phases you are getting that output R, Y, B. But Scott connected transformer means you are giving that two phases as an input and getting the three phases as an output. And this transformer will be converting from two phase to three phase. Okay. So that is the differences of Scott connected transformer when compared to single phase and three phase. Now, one I had to observe that the three phase transformer, that is R by B. Why they are always representing R by B? R means red, yellow and blue. Why these colors alone they are using? So we have number of colors, right? Pink, orange. Why these colors alone they are using in the transformer, three phase transformer? Is there any reason here? What is the reason behind these three colors are using? ఎందుకు ఈ త్రీ కలర్స్ మాత్రమే యూజ్ చేస్తారు త్రీ ఫేజ్ ట్రాన్స్ఫార్మర్స్?
They do not change their colors, sir.
It is not correct answer. So I will tell you that what the correct answer means. If you see, if we have the number of colors, but out of three, so these three alone, why we are using the three phase transformer means these three are more visible when compared to the remaining. So మనం ఎక్కడైనా అబ్జర్వ్ చేస్తే ఈ త్రీ కలర్స్ ఈజీగా ఐడెంటిఫై చేయొచ్చు, రెడ్ కలర్ కానీ బ్లూ కానీ yellow కానీ. So for identification purpose, for visualization, they are using these three colors alone, red, yellow and blue, R, Y, B. So that is the reason why we are using the three phase windings like R, Y, B. Okay now. So this is the first category and first types of transformers based on the number of phases. Now we'll see the second category, construction. So based on the construction, it is classified into three types: core type, shell type and berry type. Now from diagram we can observe that this is the core type transformer, this one and this one, this one. Okay. So how we can identify that core transformer type? Core transformer ఎలా ఐడెంటిఫై చేస్తారంటే, if you observe the transformer, the outer area is occupied by the windings. So ఇక్కడ winding చూడండి, this is the winding and this is the winding. So outer area మనకు winding తో occupied. So if you see this, the outer area is completely filled with windings. So you can easily say that this transformer belongs to the core type. Now if you see the shell type transformer, the outer surface, the outer area belongs to the core. Outer area ni core to untundi, then we can call it as a shell type transformer. And the final thing is buried type. Now this buried type transformer we are using in that real-time applications. The reason behind this, it requires that more material and more space. That's why we are not using this type of transformer in real-time applications. Most probably we are using core type and shell type. And you may get 2 marks for this question. So what is the difference between core type and shell type? So we will discuss in later. Okay, now so what is the difference between shell type and just observe this diagram here. Core type how it will be and shell type how it will be. So here just observe this diagram for core type, shell type and buried type. Okay, now next if you how the core type transformer should be means core type transformer should be look like this, and here it has the 2 limbs. If it is single phase means it has the 2 limbs. If it is 3 phase means it has the 3 limbs. Now one winding is providing on the first limb, another winding providing on the second limb. So you can simply say that the winding is surrounded by the core. Okay, now the winding is surrounded by the core. And here the shell type transformer we can say is that it should be like this. If it is single phase, then you can like it should be like this. If it is 3 phase, it is like this. Now how we can provide winding in this? If it is single phase means in that transformer one winding is low voltage winding, one winding is high voltage winding. They must be, it may be primary or secondary. First we have to wind that low voltage winding. After that, above the low voltage winding we have to provide the insulation. Then we can provide that high voltage winding. So this is the way of winding on the shell type transformer. If you take that buried type, the inner circle we can represent that low voltage winding, the outer circle we can represent the high voltage winding, and it is core. Now here the core construction is in the form of laminated construction. What is the advantage of laminated construction?
To reduce the losses.
What losses?
Hysteresis and eddy current losses.
Right. So the laminated construction is used to reduce that eddy current losses. Generally, what is the eddy current? How the eddy current losses will be generated? When the current is flow through the air gap, then eddy current losses will be generated. Okay. So these losses we can minimize by using that laminated construction. So this is the second category of transformers. Now let me see the third one. The third category of transformers is specified based on the function. So based on the function in the sense the transformer where we are using. So based on the application of area, then the transformer we can call different names. Now if the transformer using in the generating station, we can call it as a power transformer. This is the transformer look like which is using in the generating station. And next thing is instrumentation transformer. Here the instrumentation transformer has the different characteristics. What is the meaning of this instrumentation means? Generally the instrumentation transformer is again classified into 2 types. One is current transformer and the one is potential transformer. Now I will tell you that what is the purpose of current transformer and what is the purpose of potential transformer. Generally in transmission system, huge amount of current, huge amount of voltage will be available. So మన ట్రాన్స్మిషన్ చూసుకుంటే ఎక్కువ కరెంట్ ఎక్కువ వోల్టేజ్ ఉంటుంది. ఓకేనా. Now సో జనరల్ గా మనం కరెంట్ ని ఏ డివైస్ తో మెజర్ చేస్తాం?
అమ్మీటర్
వాట్ అబౌట్ వోల్టేజ్?
వోల్ట్మీటర్ సార్.
ఓకేనా. సో అమ్మీటర్ వోల్టమీటర్ అనేది తక్కువ రేటింగ్స్ ఉన్న కరెంట్ కి తక్కువ రేటింగ్స్ ఉన్న వోల్టేజ్ ఫ్యూజ్ చేస్తాం. బట్ మనకు ట్రాన్స్మిషన్ లైన్స్ లో వోల్ట్స్ అంటే కిలోలో ఉంటుంది వోల్టేజ్, థౌజండ్స్ ఆఫ్ వోల్ట్స్. అక్కడ మనం చిన్న వోల్టమీటర్ పెట్టి మెజర్ చేయలేం. దేర్ వీ కెన్ యూస్ దట్ పొటెన్షియల్ ట్రాన్స్ఫార్మర్. సో వాట్ ఇస్ ద పర్పస్ ఆఫ్ పొటెన్షియల్ ట్రాన్స్ఫార్మర్ అని అడిగితే, దిస్ ట్రాన్స్ఫార్మర్ ఈస్ యూజ్డ్ టు మెజర్ దట్ హ్యూజ్ హై రేటింగ్ ఆఫ్ వోల్టేజ్. ఎక్కువ రేటింగ్ ఆఫ్ వోల్టేజ్ మెజర్ చేయాలంటే వీ కెన్ యూజ్ ద పొటెన్షియల్ ట్రాన్స్ఫార్మర్. ఓకేనా. అలాగే వేర్ వాట్ ఇస్ ద పర్పస్ ఆఫ్ కరెంట్ ట్రాన్స్ఫార్మర్ మీన్స్ ద కరెంట్ ట్రాన్స్ఫార్మర్ ఈస్ యూజ్డ్ టు మెజర్ దట్ హై రేటింగ్ ఆఫ్ కరెంట్. ఓకేనా. హై రేటింగ్ లో ఉండే కరెంట్ ని వోల్టేజ్ ని మెజర్ చేయాలంటే వీ హ్యావ్ టు యూజ్ దట్ కరెంట్ ట్రాన్స్ఫార్మర్ అండ్ పొటెన్షియల్ ట్రాన్స్ఫార్మర్. ఈ రెండు ట్రాన్స్ఫార్మర్స్ అనేవి ఇన్స్ట్రుమెంటేషన్ ట్రాన్స్ఫార్మర్ కి సంబంధించింది. ఓకేనా. రైట్. నెక్స్ట్ డిస్ట్రిబ్యూషన్ ట్రాన్స్ఫార్మర్. This transformer is we are seeing our locality, our local areas. So this type of transformer you are using the distribution system. That's why we can call it as a distribution transformer. Now in the voltage levels, what is the difference between these two? Power transformer, distribution transformer. ఈ రెండిట్లో ఏది స్టెప్ అప్, ఏది స్టెప్ డౌన్ ట్రాన్స్ఫార్మర్? Out of these two, that is A and C, which transformer is a step up and which transformer is a step down?
C sir.
Right. So power transformer is a step up transformer, distribution transformer is a step down transformer. Then fourth one is welding transformer. This is using in the welding machines, welding works like that. We are using the welding transformer. So these are the four types of transformers categorized based on the function. Next, types of cooling. General గా మన ట్రాన్స్ఫార్మర్ లో ఒక డ్రాబ్యాక్, ఆ డ్రాబ్యాక్ ఏంటంటే హీట్. ఓకేనా. So if you observe the transformer, it is makes some noise. That noise is called as humming sound. Okay, now if you go near to the transformer, you can hear that voice that is came from that coming from the transformer, that is humming voice. So what is the purpose that sound is coming means it is already heated up. So generally in a transformer we are using the oil. So that oil we can call as lignated oil. So what is the difference between normal oil and lignated oil means it having that more viscosity than that. Okay, now so here when the oil is heated up, then we can get that sound from the transformer. Generally the cooling methods of transformer is two types. One is air cooled transformer and oil cooled transformer. So in some you can observe the substations in transformers, they are providing that fans. Okay, now what is the purpose of fans means for the cooling purpose. In some transformers they are using oil for the cooling. So these are the two categories of transformers based on that cooling methods. One is air cooled transformer, other one is oil cooled transformer. Next one is number of windings. So based on the number of windings, we have three types. One is two winding transformer, single winding transformer and multi winding transformer. Two winding transformer is example for single phase transformer. Single wound transformer is example for auto transformer, and multi winding means three phase transformer. Okay, so these are the three categories based on the number of windings. Next thing is location, indoor and outdoor transformer. So indoor in the sense that transformer which is located in the underground and accused rooms, then we can call as indoor transformer. So this type of transformer we are using in cold countries. Cold countries లో ఎలాంటి మంచు పడుతుంది కాబట్టి సో దానికి మనం ప్రొటెక్షన్ చేయాలి. సో ప్రొటెక్షన్ అంటే we are placing the transformer in the underground or one closed room. So that transformer indoor transformer అంటారు. And outdoor transformer is now what we are seeing now, the transformer we called as outdoor transformer. So this is the based on the location. And final thing is based on the rating. It is three types: low rating, medium rating and high rating. So okay students, this is the different types of transformers based on the different parameters. Okay na? So in next class, we are going to discuss about working principle of transformer and construction. Okay, students, this is about today's class. I'm going to end this class now. Thank you.